Jim, thank you so much, and to the audience who have joined, welcome to this talk. SQL Server 16 is a big release for us. We are doing many technologies, and the technology that I've been involved with in a very close quarters is the in-memory technology. And in-memory technology actually has two key flavors. One is the in-memory OLTP, which is based on memory optimized tables, and it is also known as Hackathon. This was released in 2014. And there is also a in-memory technology which we call in-memory analytics, and that is based on Columnstore. This is something that was introduced in 2012, and we continue to invest in this technology because it is a really important technology for analytics. We did a significant investment in this technology in 2014, and we continue to do that in 2016. So that's where I'm coming from. I've been with SQL Server team for the last 13 years. I've been with databases for the last 34 years. I mean, many years. I've worked for companies like Sybase, Digital Equipment Corporation, and few startups, both developing tools and applications. So I have a wide experience in databases. And as I said, I've been with SQL Server for the last 13 years. So I'm really excited to be here, and we're really excited about this technology. So the thing that I'm going to talk about is a flavor of in-memory technologies, which we are calling operational analytics. So this term is a bit confusing to a lot of people. What does it exactly mean? So what I'm going to do, I'm going to do a motivational thing. Why do we need, what exactly is operational analytics and why do we need it? And you will find that commercial database vendors like Oracle, HANA, they all are providing operational analytics. So this technology is not unique to Microsoft, but we believe it is the best implementation of this technology through Microsoft SQL Server, and I'm going to talk about why we believe it is the superior technology. And part of the reason is it has a rich set of configuration options that you have at your disposal to balance your workloads, and become obvious when I talk about that. And like we said, this technology is not unique, but the unique part that we have for SQL Server 16 is we are the first commercial vendor that is combining in-memory Hackathon technology and in-memory analytics technology together. So that combination is a very powerful combination, which can give you a significant scale up in your OLTP workload, as well as can give you pretty high-end analytics performance. So this is the first thing, first vendor to do that. And my goals for this presentation are very modest. I'm not going to go into very deep down demos. We are actually working on those demos, and we will show you those demos hopefully in the next past conference. But the key takeaways will be that you can leverage the benefits of operational analytics without any changes to your transactional workload. This is actually very powerful, because one of the key scenarios for people to adopt new technologies is, if I could do that without changing my application, it becomes that much more easier. Then you can say, okay, let me see if it is working well for me or not. If it is not, then you can always go back. So there is no changes to the application. Very powerful. Second thing is that, and I know a lot of past members are at a very different level of technical expertise. So you are at that level where you deal with lots of configurations and lots of workloads. And what we are going to provide, SQL Server shies away from providing many knobs. So I'm not saying we are providing a lot of knobs, but we are going to give you a couple of very key controls that you can balance the performance of your transactional workload against your analytics. So we're going to talk about that. And as I said, we are definitely a superior technology. That's what we believe compared to our competition. Now, this is just a statement, right? So the question is, how do we back it up? And unfortunately, as you know, there is no benchmarks that are industry standard that talk about operational analytics. So we cannot really claim any um, uh, objective way to say we are superior. But I think the facts are, in terms of in-memory analytics using Columnstore, SQL Server has released the leading benchmark numbers both with SQL 14 and now with 2016. So we definitely are leading the pack in terms of analytics. And in terms of OLTP workload, the memory optimized tables are giving us a huge gain. So essentially think about this, right? We are combining those two industry leading technologies to give you operational analytics. So we believe it is much superior. Okay. So much for that. So let me build a motivation. Why do we need real-time operational analytics? Actually, when I use the word operational analytics, um, the real term is real-time operational analytics. And I want to emphasize real-time. And why? It will become clear in this example. So this is something that I have talked as a scenario a few times before, because I think people relate to this kind of a scenario. So imagine you are a owner or a manager of a large departmental store. Let's say that, right? You are selling everything. Think of Walmart. Think of something like that, right? You're selling all kinds of merchandise, including the merchandise that is time sensitive. So, for example, you can think of, around Christmas time, you have Christmas toys and whatever not. Those are time sensitive because if they're not sold by the Christmas day, the value goes down, right? Christmas decorations. Similarly, you may have, time sensitive commodities, for example, like the milk and the flowers and stuff like that. And of course, if you can't sell them by the expiry date, you lose money, right? So what I'm showing you here is assume that you have a department store and customers are running transactions, and I'm just showing a very simple example where you buy something. In this case, you're buying a flower, and it goes into a transactional database because you're tracking through registers, right? What transactions, what people purchase, all those things, right? So this is where your customers are coming and running their transactions, and you are able to help them. And clearly, if your OLTP system was slow and your transactions are not getting through, I mean, you may lose business because people may not, like to stand in the line for a long time. They just leave. So the key point is that your transactional system has to be running smoothly, efficiently, so that you can process transactions in the right way, right? So this is what's going on, right? Now, any business today wants to do some sort of a BI on this, like what's going on in my business, my what products are selling well, what is the peak time of selling. I mean, you can do a lot of analytics, and you do those analytics to fine tune your business, figure out what things you need to sell, right? So the analytics is pretty much ingrained in any business today, right? You need to do transactional processing and you need to do analytics. So what happens, how people do analytics? So in a very common environment, right, they have this ETL. ETL could run, hourly or daily or weekly. And I think you guys, you deal with more customers than I do. But whatever I have talked to, majority of the customers are ETLing the data, like moving the data from the operational system, from the transactional system on a daily basis, right? So every night there is a job that runs, and you bring that data into a data warehouse. So now let's say I'm running that, and then you can do, for example, analytics. You can say, okay, show me where the product type is perishable, for example, and show me the quantity at hand and expiry date and things like that. You can do that kind of stuff, right? So let's say I do this query, say tomorrow, like I was looking for yesterday's transactions, I'm doing this query today. And then I can figure out, there are few products I have, their expiry date is closer to expiry, so I may want to put a promotion. I may do whatever I could do to get those commodities out of my store so that I can get some money out of that, right? So in this simple example, right, you can see that it would be good for me if I could do that analytics on my transactional system instead of waiting for a day, because by waiting for a day you may lose some opportunities, you may lose some business, and you may lose some money because you could not sell those products. So the customers are saying this kind of situation, the analytics which is day old is not good for me. I want to do in real time. You could say, well, I'm going to do hourly. Okay, still, what I'm saying is you want to react in real time. So that's the word, the real-time analytics. This is why it is important. So real-time operational analytics. What it means is I could do that in real time. Operational means my transactional workload and analytics on that, right? So that's what it is. Now, interestingly, this deployment that I'm showing you here is not, not exceptional. This is a very common deployment today. And of course, you can add analysis services, or you can do without analysis services. So pretty much that's what people have, right? Now, if you look at the challenges with this one, key issues, what are the key issues? So the key issue is, actually I'm not able to see my slide. Hold on. Okay, right. Just give me 1 second. I think so the key issue here is, number one, it is a complex implementation. Why it is complex? Because you need to create ETL, right? And ETL jobs are not easy to write, and also it is more expensive. Why? You have to hire somebody to write ETL workload, right? You need to get a new box to host the data into a database, and so there's a license, there's a hardware cost. So you can say, as a business, it's all fine, I have the money and I have the ETL done, so why should I bother? The bother is that there's a data latency in the analytics, and most businesses are saying this latency is not acceptable for my workload. When I'm making that statement, I'm going to back it up with some actually research paper I was reading. If you look at how many businesses are saying I want to do analytics in real time, it is growing. And I think this thing I was reading, I don't have the reference here, around 50 to 60% businesses prefer having analytics in the real time. So even if you say cost doesn't matter to me, but the real time matters, right? So that's the challenge. Now the question is, how do we address it, right? So I'm going to do the same thing, like the same transactional workload that we have before, and I'm going to show you that I'm running the same kind of a transactional workload, right? Nothing new here. So with 2016, this is actually important. With 2016, what you could do, you can create a column store index on a subset of your transactional table. So think of this. You're running your OLTP workload, transactions are going on, and you want to do analytics on a subset of tables. Why I'm saying subset? Because typically not every table in your transactional workload has data that you want to do analytics on, right? So a subset of tables. And you do that, now at least in theory, I want to say at least in theory, if you create a column store index, and if you assume that it is going to run analytics in a much more efficient way, which it does, now you can do your transactional workload like before, right? Nothing has changed there. You just added another index on top of it, right? So now what you could do analytics directly on your transactional tables. So you do not have to do ETL. There is no separate data warehouse, right? So you can do all those things. And of course, you can even do analysis services with that, right? So essentially what you have done is you said, instead of running my analytics on data warehouse, I'm going to run that on my transactional workload. And now, as you can see, that your analytics is as real time as possible, right? So this is what we are calling the real-time operational analytics, all right? Now this all sounds good. You may wonder why customers did not do this, say, 10 years ago, right? I mean, why should I wait for my analytics Why it was not possible 10 years ago? The reason is when you run your analytics on your transactional system, it's going to take resources, right? It's going to run large queries which can do I/O bottlenecks, and it can take CPU cycles, all kinds of stuff. And while it is running, it may cause blocking and stuff like that, right? So that's one aspect. Second aspect is, if you know, the schema that you have for your transactional system is not really suited or most desirable for your analytics, because when you think of analytics, people think about star schemas or snowflake schemas, right? So the data in the transactional system is very, very normalized, so it is not going to be as efficient, right? So those are the key factors that people said, well, I don't have the technology today, I'm saying in 10 years ago, to run both my transactional workload and analytics together. So people went with the traditional model, right? And what we are saying is that in today's environment where you have very high-end machines, number one, number two, the technology like Columnstore, you have a opportunity where you can do the analytics in real time. Okay. Now, so the Columnstore technology does provide that. When you think of HANA, when you think of Oracle, all of them are doing this real-time operation analytics because there is Columnstore. Now, the key benefits, of course, are no data latency. This is, if you think from a business perspective, if I was the store manager, I'd say, yes, this is what I want, no latency. No ETL. I mean, I don't know how many of you have worked on ETL jobs. ETLs are complicated. How do you know what the incremental data is? That may mean more complexity in your ETL process, right? No separate data warehouse, right? And challenges we talked about, right? I mean, how do you deliver a decent analytics performance without impacting the OLTP workload, right? So these challenges are not to be ignored. I mean, these are very significant challenges, right? In fact, when we were working on 2016, we talked to around 80 to 90 customers. We in fact interviewed them, and the most resonating feedback we got is, if your analytics impacts my transactional workload in a significant way, I'm not going to adopt it, because transactional workload is my money generating system, so I cannot really afford any compromise on that, right? So those are the challenges. So the question is, what did we do? Let me just do this. So we're going to talk about what did we do. So one thing to note is that this real-time operational analytics, it is not for every kind of workload, right? And for example, if your data is coming from multiple transactional systems, I'm showing you in the picture here, you're getting data from 3 different systems. Clearly, you want to do analytics on an integrated environment. You cannot really do a operational analytics on in that mode, right? You have to bring the data in. So this will be one scenario where you really cannot do a real-time operational analytics. You are compelled by this configuration, right? Second idea could be that if your analytics is, you need extreme performance for analytics, for which you need to create queues or pre-aggregate the data, the real-time operational analytics is not a substitution for that, right? So we are saying that while you have all those things, for extreme cases or situation like this, you may not be able to use real-time operational analytics, but there are many, many cases where real-time operational analytics is very relevant. And even in the configuration that I'm describing to here, you may want to do some analytics on each of these OLTP systems that I'm showing on the left side, right? You can say I'm going to do some local analytics, and then I'm going to do some integrated analytics. So what I'm saying is, these are not mutually exclusive scenarios. You could now have real-time operational analytics on one of the OLTP systems, and you could do the extreme analytics using a traditional data warehouse, right? So those are something to be aware of. So now let me just talk about what we have done for both, and you will see for both, the disk-based tables. When I think of disk-based tables, I'm thinking of the traditional SQL Server tables, which are page-based, and like those tables that you had before in-memory memory optimized tables came along, right? Those are the disk-based tables. And you notice that we provide the real-time operational analytics both on disk-based tables as well as memory optimized tables. So I'm going to first talk about the disk-based tables, okay? Now the idea is very simple, right? I'm just showing you a table in your OLTP workload. Here you have a relational table, you have a bunch of binary indexes on it, could be clustered index, could be non-clustered index, could be a combination of both. And you have many tables like that, right? Now if you figure out that I need to do analytics only on the subset of tables, right? So what you do in 2016, you create a non-clustered column store index, okay? Just like you would create any other index, what you're doing is you're creating a non-clustered column store index. Now, you may wonder, hey, non-clustered column store index was available to me in 2012, SQL Server 2012 and 14, so what is so new about that in 2016? The key thing that is new is it is updatable. In 2014 and 12, when you create a non-clustered column store index on a table, the table was marked as read-only. If the table becomes read-only, you cannot really do any transactional workload, right? So now the column store, non-clustered column store index, we call it NCCI, is a updatable index. Now, here is something interesting, and I'm not saying this is a common case. We have seen some workloads where the DBA or the administrator has created some indexes which are there to efficient query processing. Typically, you can say a poor man's indexes for analytics they create on the transaction tables. I'm not saying very common, but we have seen. Now, what you could do once you have a non-clustered column store index, you can say I'm going to drop those indexes, maybe 2 indexes, 3 indexes, and I'm going to replace that index by a single non-clustered column store index. Now, in that situation, you may consider, in that situation, you may in fact see improvement in your transactional workload because you replaced 3 indexes by 1 index, right? So that is something to think about. And the most important thing is you can do this without any changes to your transactional application because all you're doing is just creating an index. And index, as you know, is like any other index. I mean, no changes to the application. And this index is the non-clustered index is like any other index. You insert a row into your table, base table, which I'm showing you by yellow. That index row will get inserted automatically in the B-tree indexes as well as the non-clustered index. Now, other thing is, okay, so I have created this index. Now I'm running my queries. Optimizer, SQL Server Optimizer knows which query can leverage column store, so it will just run the query through that. All right. Now this technology that we have is part of 16. It is available in the cloud. And what I wanted to highlight is that the Dynamics ERP application that we have, they in fact had the traditional model where they had an ERP application and they were moving the data into some warehouse with cubes, and what they did was they replaced that using NCCI. So they are in fact, the new service that they provide is running in Azure DB, Azure SQL DB with this NCCI, and they are finding their customers are liking it. Yes, if you look at the analytics query performance, it's not going to be at that level of extreme. I mean, instead of taking, say, 0.5 seconds, if it takes 1 second or 2 seconds, I think people are saying, okay, but at least I'm getting the data in real time, right? And it, of course, reduces the cost. And we have, as part of our CAP program, the Microsoft product team work with customers to validate the technology, and some of those customers go in production before RTM. We have one extra customer who's deployed NCCI and running in production. And so what I'm trying to say is that as this technology comes out, hopefully after RTM, people will adopt it more and more. So we will see that. So that's where it is. It's a real technology. And now let me make a couple of points about how expensive it is to maintain this index. Okay, so what I'm showing you here is comparing if you had a traditional B-tree index versus a non-cluster column store index, okay? I'm assuming in this presentation that you guys know about column store, have background in that one. If you don't have any background in column store, can you please IM us, and I can spend a few minutes on column store technology in general. Otherwise, I'm just going to go through maintaining what is the overhead of maintaining a non-cluster index on a traditional table. Okay, I think this is important because this will build the base for the next slide. So in a simplistic way, when you think of column store, think of this. You have data stored as column, highly compressed, but when you insert a new row, right? I'm inserting a new row. A row by itself cannot be compressed, right? We need multiple rows to compress, get a good compression. So what we do behind the scene, behind the covers, when you have a column store index, we have a lot of data, most of the data sitting in the column store index format, but we also have an internal B-tree table, row store table, that is keeping the new rows that get inserted into that index, right? So think of this, you have say 10 million rows, maybe 9.5 million or 9 million rows are sitting inside compressed stores, and the new rows that are coming in are going into the row store, which we call a delta store, which is part of the column store, right? The rows are coming there, and once those rows exceed 1 million, we compress them, right? That's what it is. So now think of this, right? If I do an insert operation and you have a non-cluster index, it is just like inserting a row into a B-tree. In this case, it happens to be a delta store, right? So it's just going to go there. So there is no difference there. Now the delete, I think, is interesting. So let's say I delete a row from my base table. If I have a B-tree index, I need to find that row across all B-tree indexes I have defined on the table, right? I'm going to search the key, find the row, and delete it, right? So seek and then delete the row. Now with the column store, this is one thing that I want to highlight is, number one, column store index has no key columns. Okay, this is maybe non-intuitive. It's an index, we call it an index. The way I think about it, it is more of an organization. Column store organization is not really an index in the traditional sense when you think of keys. There is no key in the column store index. Okay, so now let's say I come and delete a row with employee ID 10. And now question is, how do I find that row in the column store? Because I need to delete that row. So remember we talked about these delta stores? The delta stores actually are organized. Let's take a very simplest example. You have a cluster index on your base table. So the delta stores behind the scene are organized in the clustering key column of your base index. Okay, so they are ordered in the same way, right? So now what you do, I delete the row from the base table. I will search my delta store with that key. If I find it, I delete it and I'm done, right? If I don't find it, then I need to search in the compressed part, right? In the compressed part, there is no easy way to find that row. So what we do is, there's a new concept we call a delete buffer. I mean, underneath, if you look at these indexes, they're complex. So we maintain almost like I would say another B-tree, right? B-tree is a very common storage format. What we do, we keep track of the row that we deleted. So we don't search in the compressed store, we just store somewhere that this row has been deleted. Now what it means is when you run the query, the analytics query, we need to filter that row out, right? So that's the logic that we have, right? So the way the delete works is, you search in the delta store. If you don't find it, if there's multiple delta stores, you search in the next delta store and so on. Once you exhaust that, then you insert a row into this delete buffer. Actually, this delete buffer is an internal B-tree. That's where we keep it, right? So as you can imagine, this makes the delete operation more expensive, right? Because you are searching, if you have multiple delta stores, you are searching through each of the delta stores and then inserting the row. And that can impact the DML operation on your transaction system, right? So something to keep in mind. Third thing is when you do update actually with the column store is done not in place. Okay, this is something that we're thinking about, but at least in 16 it is not in place. So what you do delete. That means you're doing the same overhead we talked about, and then you do an insert. Insert is easy, right? Insert just goes into the delta store. This is how you're maintaining the column store index. So one takeaway is that the column store index is indeed more expensive, right? So what have we done about that in this release? Okay. So let me just go through that. So this red thing that you see are the challenges that we just discussed. So what we have done is I'm going to go through each of those. Some of you may not know that the data store for column store was organized with page compression on. Now when you think of data store, it was a transient row store, because once the rows become 1 million, you will compress that and throw away the data store, right? So the benefit of having a page compression was questionable, right? But it was chosen to be page compression. So what we have done is we have in 16, there's no page compression in the data row group. What it means is inserts will be a bit faster because we are not going to compress the data, right? That's one. Second thing that we have done for the data store is the data store. I think I talked about that you have each data store of size 1 million rows, right? And if you have a next data store, the next 1 million and so on, right? So if you had, let's say, 15 million rows sitting in the data store, you may have 15 data row groups, right? So that means your delete operation will be slow because you have each of those data row groups. So what we have done is, this happens automatically, we create data row groups with the exponential increment in the size. So first data store will be 1 million rows, second will be 2, then 4, then 8, 16, and 32. At 32 we cap. So by doing that, we are reducing the number of data row groups that you can potentially have. Now you may wonder, hey, if I have a data row group of size, say 4 million rows, when I compress that, do I get 4 million row compressed row group? No. 4 million, we will create 4 compressed row groups, right? That's how it goes. So that's that. And other important, this is actually a very critical point, unlike a traditional data warehouse, if you are running OLTP workload and you have a column store index on top of that, you will see a lot of updates, delete, and inserts, right? And as I said, when you do update or delete, it is done as a delete followed by an insert. So you may see a lot of deleted rows in a compressed row group, which may mean that how do you garbage collect those rows? Because when you delete a row in a compressed row group, you don't physically remove the row, because there is no easy way to remove the row from the compressed row group. So how do you garbage collect them? So the only technique that you had available was to rebuild column store index, but that could be expensive, right? So what we now provide is a index defragmentation, just like you do for any other B-tree, alter index, reorganize. You do the same thing for column store index, and it will remove the deleted rows based on certain policy. Of course, if you have only one row deleted, we will not remove that, stuff like that. So that's a policy. It's actually documented in books online. Okay, so now let me focus on the key technology, what we have done to minimize the column store index overhead. Remember, we talked about low page compression, exponential data row groups, and reorganize, right? Additionally, on top of that, what we have done is, let's say we have this traditional table. You create a non-cluster column store index. Remember, I'm showing you the purple bars. These are column compressed, and there is a data row group that is sitting, which is happening automatically, right? So now with 2016, what you could do is you can say, I want to keep my rows in a data row group for, let's say, 4 hours. Why would you do that? When we talk to our customers, they said, you know, like in many cases, my data lands, it stays hot for some time, and then it becomes cold. A way to think about this one is, let's say you are ordering something online. When you place an order, and ultimately order is processed, packaged, and then shipped. Once the order is shipped, it becomes cold. There are not too many changes to the order, right? So the data has, in many cases, a natural tendency to be hot for a certain time, and then it becomes cold. So what you could do is you can say, I'm going to see the data row group, I'm going to make it bigger now. So basically you have an option at the index level to say, I want to keep my rows in the data row group for 4 hours or 24 hours and whatever not, right? So you will keep it there. It is still part of column store, but you're keeping in data store. Now the benefit of this one is that the processing of delete update is much more efficient in the delta row group than it is if the row was compressed, right? So by controlling that, you are minimizing or reducing the overhead of column store index maintenance. So that is one option that we are providing. Now the second option is also quite interesting. So that we call a filtered, non-clustered column store index. What it means is you can say, you can choose a condition and that condition will only compress rows or add rows in the column store which are meeting the criteria. Okay, so I'm going to talk about this filtered non-clustered column store index, right? So here is something that you should see before I go into detail. So the data that I'm showing you as hot, right? These are the rows that do not meet the filter condition, right? This is hot. And for the hot data, there is no index. The index is only on the cold data or the warm data, right? On the left of the hot. So what it means is, if you are making any changes to the data that is hot, you're not really paying any overhead of the column store index. Now, overhead we talked about in the slide before, right? So no overhead. So you're inserting row, it goes to the hot data, you update the row, it is just updating. So from your transactional workload, you're not really paying any overhead for the columns. So this is one option. Another option that you have available which can minimize the impact on your column, on your transactional workload, because you have created a non-clustered column store index. Now you may wonder, hey, okay, I do that, but when I run my analytics query, how will I pick the data from the hot part, because there is no column store there, right? And we are doing real-time operational analytics. I do not want to miss my hot data, right? So this is something unique that we have done for the column store index, filter index inside the SQL Server engine. When SQL Server Optimizer chooses a non-cluster column store index, which is filtered, it will automatically scan the hot data behind the scene. So you will get real-time analytics even in this case. Okay. Now, one common example for this hot versus cold is like think of a order entry system. We touched upon that before. So you can say once order is received by the consumer or the customer, I will consider that to be cold. So you can say create a column store index where the status of the order is received, right? So in general, that data does not change unless, of course, customer wants to return the item, which is not common. So by doing that, you can minimize the impact on the transactional workload. All right. So this is something that we have done both. So we call the first thing where you can control when the row gets compressed as a compression delay. So you can control compression delay. That option is available both for memory optimized tables and disk-based tables. And also you can use filtered index. All right. So those are the two combinations that we could do to reduce the overhead of the transactional workload while still delivering the real-time operational analytics. Now I have like 20 minutes. So what I'm going to do, I'm going to go to the real-time operational analytics for memory optimized table, and then I'm going to do a demo which will combine the both. Right. Any questions so far? I know you guys have been quiet. I don't see the.
So Sunil, we do have a few questions.
Okay.
We have one there. They want to know if you can give a quick overview of what column store is.
Okay, I can. Any other question? Just give me 2-3 questions. I'm gonna combine them.
They were you know, they were asking what column store is.
Okay.
And another one just came in. Any plans to make the hot data filter be non-deterministic, i.e. last 2 weeks?
When you say last 2 weeks, you can say if you say the data is, if you compress the delay, if you introduce compression delay and say 1 week, we only have a limit of 1 week. So anything that was inserted, added, deleted, I mean deleted doesn't count, for the last 1 week will not have it will stay in the delta store. So I'm not sure whether I understood the question completely, but I will request the person to send me an email. I will be happy to answer either that or we can talk offline. All right. Now the column store index, right? So this is actually very interesting. So let me spend literally 3-4 minutes, and I'm going to go to memory optimized table. So traditionally, when you think about, right, the rows, you look at Oracle, you look at Sybase, so whoever, right, the data in a table is inserted into pages, right? So what you have, suppose you consider a table of say 10 columns, you create a row, I'm inserting a row, column C1 through C10, I'm going to insert that row, then I next row and so on, right? And you collect all these rows into a page. Once the page becomes fully allocated, new page, right? But the key thing is that data is stored. Question? No. Okay. So that means the data of all columns are stored together. Now this storage format has been very successful. I mean, people have been using this format since late 70s till now. What we are finding is this format is most suited for transactional workload where you are accessing very few rows, right? I'm inserting my order, I'm looking at my order, stuff like that, right? So we have this accessing few rows. When you think of analytics, where I'm analyzing rows, even billions of rows, I mean, this is actually not uncommon now. I'm running some analytics on billions of rows. And the interesting pattern about the analytics is that you are not analyzing or you're not running analytics on all columns of the table. You may look at the sales column, you may look at some product, and so on and so forth, right? So you are looking only at a subset of columns. Now, with the row store, if I'm looking only for column C1 and C4, and you read, you're also reading other column, right? 10 column table, you're also reading other 8 columns that you really don't need for your query, right? So that's a challenge. And this challenge becomes much more pronounced when you have billions of rows, because then you are wasting, I mean, literally, if you assume all columns are the same size, 2 columns versus 10 columns, you're adding IO 5 times, right? If I could just use those 2 columns, I can reduce my IO by 80% because I was getting right? So that means if I could store the data in column storage format rather than the row format, I can get benefit for my analytics. So that's the rationale behind the column store. Now the way the column store is stored, we store each column independently. So I'm going to store column C1, then the C2, and then the C3, and so on and so forth, right? And since the data is all of a single column is stored together, I can get very good compression. So we can get like 10 times compression on average. That's what we have seen, 10 times compression. So you compress C1 separately, C2 separately, and so on. And now, when you are doing analytics on column C1 and C4, you just read those 2 columns and you process the data, right? So that's what the column store index is all about. Now, if you do a select star on the table, it will be more expensive because row columns are not sitting together. You have to figure out the column for a given row R1, where is the column C1, what the column C. You see what I'm saying? Because it will be all mumble jumble, it's not going to be stored together. So that is more expensive. But that's not the scenario for the analytics, right? So that's in short what column store index is all about. So what I'm showing you here is that purple guys, those are like you can think of each purple box is representing 1 column. And so in this example, I have like I think 10 columns, and then you see a second row of those boxes. And what it shows is we don't suppose you have a billion rows. We don't compress billion row of column C1 together. We break them into chunks of million rows, right? So we store million rows, compress million, then the second million row compress, and so on. So this is something what we call as a row group. And this concept that you will see both in Oracle and HANA and everywhere else, right? So this is how the column store is stored. So I think that's pretty much what I wanted to say about column store. I have many blogs about column store technology, stuff like that. I'll recommend you to search with Sunil as a name, column store, and you will get to the blog, right? Any other question besides that?
Somebody wants to, can you talk about how SQL identifies hot, cold data in the column store? And okay. The other one was some difficult to manage memory working with column store on 2016.
Got it. So let me answer the first question because that is very relevant for the picture that I have on the screen. So let's say I'm running a query and optimizer chooses column store. So I go to the purple box and the delta row group, right? So I figured that out. Now the question is, how do I find the hot data, right? In the worst case, you may have to scan the relational table completely, because how do you know which rows have order marked as not shipped, right? Or not received. So it can be very expensive. So what we recommend, this is our best practice, that you choose the filtered non-cluster column store index on the column on which you have cluster index on the base table. So imagine if I have a cluster index on the base table and I have actually a demo to show that, then you can identify very quickly, because that'll be just a range scan. So let me do this. I'm going to move to my memory optimized table, and then I think in the demo I'm going to cover that one. Okay, so the real-time operational analytics. So this is a visual which essentially showing that we have two technologies, both in-memory OLTP and in-memory column store. And what we are doing is we are combining the two. What you see here is, I go up a little bit, what you're going to see is that my column store is vertical on the right box and row is showing horizontal, and we combine them. So essentially what you're doing is you are creating a column store index on the same table. So essentially the point we were discussing with NCCI, and this is what we wanted to show about the column store and in-memory combined together. Okay, so let's talk about for 5-10 minutes about in-memory OLTP and the column store. So what I'm showing you here is a memory optimized table. It has two kinds of indexes. A range index, which is similar to B-tree index, but it is not B-tree from the storage perspective. It's a range index. And also you can have one or more hash indexes. So those are the two kinds of indexes. These are new indexes that are only available for memory optimized tables. All right, so you create those indexes. So this is what I'm showing you. You have a workload that you have converted to memory optimized table. You've chosen maybe a subset of tables to be memory optimized. So that's sitting disk-based, right? Now you want to do analytics on it, right? Real-time operational analytics. So you figured out which tables I need to create column store index on. That could be a combination both for in-memory tables as well as disk-based tables, right? So we already talked about how you create a non-cluster column store index on a disk-based table, and now you can create a column store index on a memory optimized table. So something to see. As soon as you create an index on memory optimized table, we are compressing the data that you see in the purple bar at the bottom and the deleted rows table. This is actually an interesting point. I touched upon that, but I think I want to emphasize again. When you have a row store and I want to delete a row, you go to a page, right? You go to an index, find the row, and you just remove the row from that page. It's gone. With the column store, the data is compressed in a very complicated way. It's very hard to find. You can't really delete the row, right? Because once you remove the row, what do? You recompress those columns, and that would be very expensive, right? So what we do is we just mark the row as deleted. This is what I'm showing you as deleted rows table in the memory optimized table. This is going to be created internally automatically. You don't have to worry about that, right? And the reason we have that table is when you run the query using column store, we need to filter these rows out, of course, because those are deleted rows, right? So that's the basic concept. So this is the column store index. Now the beauty with the memory optimized table is actually significant. And so what happens is, remember we were talking about the delta row group with the non-clustered column store index, right? There was a separate row store. What we do with the memory optimized table is we don't really have a delta row group explicitly created for column store index. Okay, so I'm going to repeat that. There is no explicit delta row group for memory optimized table. What I'm showing you as a delta row group is a virtual delta row group. Now what does virtual mean? So what happens is, let's say I come at 10 in the morning, I create a column store index on a memory optimized table, right? Everything got compressed, right? Now after 10 in the morning, I'm inserting rows, right? Inserting rows into memory optimized table. They are just going to stay in the memory optimized table, just there, and once that count grows beyond 1 million, we will compress them, okay? So now the beauty of this one is that, and that's why I'm calling it a hot data. That means any changes that you're making to those table on those rows in the hot portion, there is zero impact of column store index, right? Because you're not really doing anything. So that means your workload can run without any impact as long as you are working on the hard data. Now, just like we talked about compression delay for NCCI, you can say, I'm going to keep my data because my data stays hot for 4 hours. I show it bigger, like, you see that? I can control that. I can say compression delay for my, you only compress the rows that are more than 4 hours old. You can say that. So that means until then the data is hot, your OLTP transaction will run just like before. And as I said, when you run a query on the analytics query on this table, we will get the purple rows, right? The purple rows, the vertical rows, and we will also the hot rows automatically and give you the real-time operation analytics. Now, I think the question that was asked about how do I identify the hot row? As you know, there is no cluster index on memory optimized table. So how do I find the row in a very efficient way? Clearly, you could have a range index, but we don't do that. What we do is something very unique. We know that you have a column store index. The rows that are not part of column store index, we use a different memory allocator. So we essentially think of this, right? All the hot rows that belong to this table are sitting in a special memory area. So when you run the analytics queries, we search for the rows in that special memory allocated area. We find all the rows in that area, and those are the hot rows, and we can do analytics. So you don't really need an explicit index to do that. So that's how it is done for the memory optimized tables, right? So think of this one, right? In both cases, when you have disk-based tables or memory optimized tables, you can create column store index. You can get real-time operation analytics without changing the transactional application. And we pick up the hot rows transparently, automatically. You don't have to do any magic yourself, right? Okay. Now the final thing is, like we talk about, well, you create a non-cluster column store index or column store index on memory optimized table. There's a impact on maintaining the index, and I showed you how do you minimize that impact, right? Now, even if I do that, right, I need to run my query, which will take cycles, CPU cycles from my system, right? Now, one option that you have with SQL Server 16 is if you are running your transactional workload using always on readable secondary, right? So this is what I'm showing you. You have one primary replica and 3 secondary replicas, right? Now what you could do is, yes, you have to create column store index on the primary replica, but you can offload your queries directly on the secondary replica. So that means your primary replica is only paying the cost of maintaining the column store index, and we showed how you can minimize the impact of column store index maintenance using compression delay as well as the filter column store index. So that's the final thing that you could do to minimize the impact. So I know my time is up. So let me first summarize that and take questions. And I think I'm going to skip the demos. And I'm going to do one thing. I'm going to create demos in a webcast, and I'm going to send it to you all who was interested, and you can see that. So the key thing that I wanted to capture was that I hope you appreciate or have a better understanding why real-time operational analytics is desired in businesses today, because people want to analyze data in real time. And the option that is available from Microsoft SQL Server 16, we have a rich set of options, both compression delay and filter index, to minimize impact on the transactional workload. As I said, we're the first leading commercial database that combines both in-memory, memory optimized technology as well as the column store technology. Now, you can do real-time operation analytics without any changes to your transactional workload. And there are ways. I mean, you may wonder how much change I need to make for my analytics. There are ways to minimize that impact, because you have to now write the query with the different tables now, right? Because when you had your queries running in a traditional data warehouse, you had fact tables and dimension tables. Now you cannot just run the same query as is on the transactional system because tables are different. You can hide that using a view, but I think that is something to think about. And we, in fact, have a superior technology compared to Oracle 12c and HANA. I don't have time to talk about those technologies, but if you research about those technologies, the solution that Microsoft SQL Server provides is superior. And as I said, there is no industry standard benchmark for us to prove the point, but that's where we are. I think that's pretty much my time here. I'll be happy to take any questions.
Yeah, so one more second here, and then what I'll do is I'll stop recording, and we can finish out the remaining questions we have. I just wanted to thank everybody for joining us today for Sunil's presentation. If you want to stick around for the questions we ask, you're more than welcome. But we're going to stop recording now, and again, thank you very much for attending.